Hello everyone, today I am going to teach you question number 6 from Conditional Trigonometric Identities. In first video I already provided you 5 questions from Conditional Trigonometric Identities. So I brought for you question number 6. If a plus b plus c is equal to pi, prove that sine 2a, sine 2b and sine 2c is equal to 4 sine a, sine b and sine c. This is different type of question. On previous video you seen here sine a, sine b and sine c is there, but here I brought for you sine 2a. This is different pattern. So this one is part 2 and part 1 from question number 1 to 5 already provided. Now look at here how to solve this. Here what is given, condition is given here, a plus b plus c is equal to pi. Here a plus b plus c is equal to pi. On my previous video you seen here was a by 2, b by 2, c by 2, so I divided here by 2, but you can see in RHS here is a, b, c, so it means no need to multiply, no need to divide by 2. So we can write here a plus b is equal to pi minus c. After this we have to take sine both side and cos both side. Taking sine both side, it means sine a plus b is equal to sine pi minus c. Sine pi minus c, pi means no need to change and pi minus c means second quadrant. In second quadrant sine always positive, so we can write here sine c. Similarly when you take here cos both side, cos a plus b is equal to cos pi minus c. Pi means 180 means no need to change, and pi minus c means second quadrant. In second quadrant cos is negative, so we can write here minus cos c. Hope you understand this condition. After this we have to take LHS. In LHS what is here? Sine 2a plus sine 2b plus sine 2c. Now you have to take only two terms and we have to use formula of sin c plus sin d. Sin c plus sin d formula is 2 sin c plus d by 2 cos c minus d by 2. If you don't know the formula, I was already uploaded formula video of trigonometry. You can go on the playlist of formula and you can see the complete formula of trigonometry. Now here we are going to use the formula of sin c plus sin d. And the formula is 2 sine c plus d, 2a plus 2b, c means 2a, b means 2b, 2a plus 2b by 2 cos c minus d, 2a minus 2b by 2. C and d, sine c plus sine d, 2 sine c plus d by 2, c means 2a, d means 2b, and cos c minus d by 2. And this one sine 2c formula is 2 sine c cos c. Formula of sine 2c is 2 sine c cos c. Now 2 sine, when you take here 2 common, what is remaining here? A plus b by 2, 2 to cancel. Similarly cos, taking 2 common, remaining a minus b by 2, here also 2 cancel, plus 2 sine c cos c. Hope you understand up to here. And after this 2 sine a plus b cos a minus b plus 2 sine c cos c. Now you can see what is the value of sine a plus b. Sine a plus b we found already here. Sine a plus b is sine c and cos a plus means minus cos c, but here we have to put the value of sine a plus b, and the value of sine a plus b is sine c. So in the place of sine a plus b we have to write down sine c. It means 2 sine c cos a minus b plus 2 sine c cos c. Now you can take here common, and the common is 2 sine c, so we can take here common 2 sine c, and the remainings are cos a minus b plus cos c. Now you can see once again here cos c, we have to put the value of cos c. And what is the value of cos c here? Cos a plus b. Cos a plus b is equal to minus cos c. It means cos c is equal to what? We have to write minus cos a plus b. Cos c is equal to, now you can write here 2 sine c, here cos a minus b, cos c, the value of cos c is minus cos a plus b, so we can write here minus cos a plus b. You can see here this is in the form of cos a minus b minus cos a plus b. This is in the form of cos c minus cos d. 2 sine cos C minus cos D, we have to use formula. And what is the formula of cos C minus cos D? Minus 2 sine C plus D by 2 sine C minus D by 2. So you can use here 2 sine C and cos C minus cos D formula, 2 sine A minus B, C plus D, A plus B by 2 sine C minus D means A minus B minus A plus B by 2. It is also minus 2 sine C plus D by 2 sine C minus D by 2. So we can write here 2 sine C minus 2 sine B and B cancel, A plus A, 2A by 2. Similarly this side, A and A cancel, minus B, it will be minus 2B by 2. Here is minus into B, minus 2B. Okay, 2 sine C minus 2 sine, 2 and 2 cancel, A, 2 and 2 cancel, sine minus B. Minus sine minus B means minus sine B. So this minus and this minus, it will be plus 2 into 2, 4 sine A, sine B, sine C. We have to prove 4 sine A, sine B, sine C, which is here RHS proof. Hope you understand this question number 6. Now look at question number 7. And the question number 7 is, if A plus B plus C is equal to pi, prove that sine 2A, sine 2B minus sine 2C is equal to 4 cos A, cos B, cos C. We have to prove. Here, one condition is given here, A plus B plus C is equal to pi. Either we have to multiply or divide. It depends on RHS. You can see here is A, B, C. So no need to divide, no need to multiply by any number. It means we can write A plus B is equal to pi minus C. After this, taking sine both side and cos both side. When you take sine both side, it will be sine A plus B, and this side sine pi minus C. Pi means no need to change, 180 means no need to change. Pi minus C means second quadrant where sine is positive. So we can write here sine C. Similarly, taking cos both side, cos A plus B is equal to cos pi minus C. Pi means no need to change, so we have to write down cos. Pi minus C means second quadrant. In second quadrant, cos is negative, so we have to write minus cos C. Now taking LHS, sine 2A plus sine 2B minus sine 2C. Now you can see when you take two terms, first and second, this is in the form of sine C plus sine D. And what is the formula of sine C plus sine D? 2 sine C plus D by 2 cos C minus D by 2. So we have to use here same formula, 2 sine C plus D. In the place of C you can see here is 2A, and in the place of D you can see here is 2B. So we can write 2A plus 2B by 2 cos C minus D, 2A minus 2B by 2 minus sine C. Or you can write down the formula of sine 2C also. Sine 2C formula is 2 sine C cos C. Or you can write down in next step sine, when you take 2 common, remaining A plus B by 2, 2 and 2 cancel. Similarly here cos, taking 2 common, remaining A minus B by 2, 2 and 2 cancel, remaining sine 2C. 2 sine A plus B cos A minus B minus sine 2C. Now what is the value of sine A plus B? From here we can see sine A plus B. The value of sine A plus B is sine C. So in the place of sine A plus B we have to write down sine C. So we can write here sine C cos A minus B minus cos 2C formula is 2 sine 2C formula is 2 sine C cos C. After this you can see here also 2 sine C, here also we can see 2 sine C, so which is common, so we have to take common here 2 sine C, and the remaining elements are cos A minus B minus what is remaining here, cos C, so write down cos C. Now after this step we have to put the value of cos C. What is the value of cos C here? Cos A plus B means minus cos C. It means what is the value of cos C? Minus cos A plus B. So in the place of cos C we can write minus cos A plus B, minus it will be plus. So minus cos C value is cos A plus B. So we can write here 2 sine C cos A minus B plus cos A plus B. Cos C plus cos D. In the place of C here is A minus B, and in the place of D here is A plus B. This is in the form of cos C plus cos D, and the formula is 2 cos C plus D by 2 cos C minus D by 2. So 2 sin C, 2 cos C plus D, A minus B plus A plus B by 2 cos A minus B minus A minus B by 2. So 2 sin C, 2 cos B and B cancel, A plus A, 2A by 2 cos, here A cancel, minus 2B by 2. 2 cancel, here also 2 cancel. So what is remaining here? 2 sin C, 2 cos A, cos minus B means cos B. When you multiply this, we get 4 cos A cos B sin C. But you can see here in RHS what is given, 4 cos A cos B cos C, which is mistake here question. So you can write here sin C. We got here sin C. 4 cos A cos B and sin C is the correct answer. Here maybe print mistake, so you can remove and write on sin C. So hope you understand this question. Look at the question number 8. Question number 8 is, if A plus B plus C is equal to pi, we have to prove that cos 2A, cos 2B and cos 2 is equal to -1 minus 4 cos A, cos B and cos C. Here one condition is given, A plus B plus C is equal to pi. First of all, we have to take condition and we have to solve. A plus B plus C is equal to pi. After this, A plus B is equal to pi minus C. Sometime you will get here A by 2, B by 2, C by 2. That time you have to divide by 2. Sometime you will get 2A, 2B, 2C. That time you have to multiply by 2. It depends on RHS. Either we have to divide or multiply. So here you can see here is ABC. So no need to divide, no need to multiply. After this, we have to take sine both sides. Sine A plus B is equal to sine pi minus C. Pi means no need to change. Pi minus C means second coordinate. In second coordinate, sine is positive, so we can write here sine C. Similarly, taking cos both side, cos A plus B is equal to cos pi minus C. Pi means no need to change, so we have to write here cos. Pi minus C means second coordinate. In second coordinate, sine and cosec only positive, cos is negative, so we can write here minus cos C. Now, after doing this, we have to take LHS. In the LHS, cos 2A plus cos 2B plus cos 2C. From here, we have to take first two term and we have to use the formula of cos C plus cos D. This is in the form of cos C plus cos D. In the place of C, here is 2A, and in the place of D, here is 2B. And the formula of cos C plus cos D is 2 cos C plus D by 2 cos C minus D by 2. If you don't know the formula, please visit on my playlist. There is the complete formula of different exercise, different chapter. You can understand. You get trigonometry complete formula. So I'm going to use here the formula of cos C plus cos D, and the formula is 2 cos C plus D by 2A plus 2B by 2 cos C minus D. C minus D. C means 2A, D means 2B. 2A minus 2B by 2 plus cos 2C. 2 cos, taking here 2 common, remaining A plus B by 2. Similarly, here also same, we have to take 2 common, remaining A minus B by 2 plus cos 2C. 2 and 2 cancel. So 2 cos A plus B cos A minus B plus cos 2C. 2, you can see here this is in the form of cos A plus B, and we have a value of cos A plus B is minus cos C. So we can write here minus cos C. Cos A minus B we have to write on same plus. Now we have to use formula of cos C. Either we have to use formula in the form of sine, either we have to use formula in the form of cos. Which one we have to use formula? It depends on this. Cos c is here, so cos 2c formula, two formulas we have to use. Either we have to use 2 cos square c minus 1, or we have to use 1 minus 2 sine square c. But here is cos, so we can take common also. So here we have to use formula of cos, and the formula of cos 2c is 2 cos square c minus 1. Minus 1 in RHS you can see here we need minus 1 also. So that minus 1 you can write down front, and you can take common. Here is 2 cos c, 2 cos c, so common is 2 cos c, and the remaining cos a minus b. When you take minus common, you have to change the sign, so in the place of plus we can write minus. Cos c is remaining, 2 already common here. From cos square c, cos c common, so remaining cos c minus 1, which is in front. Now you can see here, this is in the form of cos a minus b minus cos c. Again we can put the value of minus cos c. What is the value of minus cos c? Cos a plus b from condition. So we can write here minus 1 minus 2 cos c cos a minus b. Now here minus cos c, and the value of minus cos c is cos a plus b, so we can write here plus cos a plus b. Okay, minus 1 minus 2 cos c. Now you can see this in the form of cos c plus cos d. What is the formula of cos c plus cos d? 2 cos c plus d by 2 cos c minus d by 2. So same formula we have to use here. 2 cos c plus d means a minus b. C means a minus b. B means a plus b. C plus d, a plus b by 2 cos a minus b. A minus b minus a minus b by 2. Okay. Minus 1 minus 2 cos c. 2 cos b cancel. 2a by 2 cos. Here a and a cancel, minus 2b by 2. 2 and 2 cancel. So remaining minus 1 minus 2 cos c, and here 2 cos a cos minus b. When cos minus b, you can write cos b only. So minus 1 minus 2 cos c, 2 cos a cos b. Okay, minus 1 minus 2 into 2, 4 cos a cos b cos c. RHS proved. Hope you understand this question. Now look at next question number 9. And the question number 9 is, if a plus b plus c is equal to pi, prove that cos 2a cos 2b minus cos 2 is equal to 1 minus 4 sin a sin b and cos c. What we have to do, first of all, condition is given here, a plus b plus c is equal to pi. Same like before, a plus b plus c is equal to pi, then a plus b is equal to pi minus c. Then we have to take sine both side, and we have to take cos both side, and after that we have to take LHS, cos 2a cos 2b and minus cos 2c, and after this we have to use formula of cos c minus cos d, and the formula is 2 cos c plus d by 2 cos c minus d by 2. Continue it. Cos 2c formula we have to put, and the formula is 2 cos square c minus 1, and another is 1 minus 2 sin square c. So which one is front? After changing, same like previous question, you have to use here formula. If sine is front, so we have to use formula of sine. If cos is front, we have to use formula of cos. Okay, then we have to take common, again we have to use formula. Hope you can do this question number 9. Now upcoming videos related with a different question of conditional trigonometric identities, which is in square. Like this you will get question cos square a plus cos square b plus cos square c. Cos a one done, cos 2a one done, sin a, sin 2a also done. Now square one is remaining. So in next coming videos related with square, hope you can understand. If you like my video, please hit the like button. If you are new on my channel, please subscribe, and don't forget to share with your friends. Thank you so much.